in terms of its validity, different kinds of validity that we will be focusing on, like the convergent validity, the discriminant validity, and the nomological or the phase validity. So all those validity factors are to be confirmed. Plus there is a reliability check also. So there are a number of indices based on which this confirmatory factor analysis takes place. But one thing that we must keep in mind, that the SPSS, the fundamental software of SPSS that we are very accustomed to use, that is the IBM SPSS, that we actually used yesterday. Unfortunately, it has certain certain restrictions in the sense that confirmatory factor analysis cannot be conducted with that particular software. So they have extended module which is called SPSS AMOS, IBM SPSS AMOS. So we use AMOS, and the full form of AMOS is analysis of moment of structure. Apart from AMOS, there is another software which helps us conducting the confirmatory factor analysis. It is called LISREL, LISREL. So over the internet, you will find LISREL student version. Student version is freely available. So you can download LISREL student version, because again, AMOS is a proprietary software and it is very costly. And there might be scholars or researchers who might not get an access to AMOS. So if you are not getting access to AMOS, you can do the confirmatory factor analysis with the help of LISREL, the student version. And this LISREL student version also helps you to move one step forward. That is, after conducting the factor analysis, when we will be switching to again dependence method, that means we will have a model, a kind of a structural model. We can conduct the structural equation modeling also with the help of that LISREL software. So LISREL can be used, the student version can be freely used in place of AMOS to conduct the confirmatory factor analysis. Now, to start with, let us have an understanding about where exactly the exploratory factor analysis and confirmatory factor analysis differ. Now, if you focus on a very general way, in case of an EFA, as the name suggests, that it is a kind of exploration. So the researcher does not have mandatorily any working hypothesis in his or her hand, or any kind of theoretical support. So any kind of existing set of variables, it may not be there. Variables may be generated, particularly when you are trying to develop a new scale. Items have to be generated, or the scale items have to be generated, although you require support from the extant literature. So all these variable identification, or finalizing the variables that will be included in the preliminary scale, to construct the preliminary scale, it will come from the literature review. So you study the literature and you identify the variables which are suitable in the context of your study, keeping in mind your research question, keeping in mind your research objective, and you generate all the scale items or the variables. Okay, those will be those will be your observed set of variables. That means you are supposed to generate response based on those variables. In scale construction, yesterday we saw there can be, when we say we are fixing certain items for the scale, or the variables for the scale, the variables may be in the form of full statement. Okay, so against those full statement or sentences, you are supposed to generate a response, say by using an interval scale or by using a ratio scale. It has to be a metric kind of a data. So as a researcher, when you are opting for EFA, you do not have any working hypothesis, or you do not have any a priori measurement model or the knowledge about the factors. Okay, but in the CFA, in the confirmatory factor analysis, it has to be backed up by a theory, because when you are doing a factor analysis, there has to be a very clear cut model in your mind, that how, because we will be moving towards identifying the latent construct. The latent construct have already been identified in EFA, because we are stopping there. Once we identify the factor structure, we are stopping at EFA. And identifying the factor structure means we identify the factors that are basically the underlying kind of a structural layout, and just beneath that superficial data. Superficial data means superficial variable set. So at the manifested level, there will be the set of variables, or there should be the scale items. Just beneath that particular stated variable or manifested variable or observed variable lies the underlying factor structure. So each factor is basically responsible to, you know, define all those variables, or with the help of a group of variable, a particular factor may be defined. We will come into the different kinds, two different kinds of models. One is a formative model, the second one is a reflective model. So either the observed variables can explain a latent factor, or a latent factor can influence the observed set of variables. So in either of these two cases, we will have two different kind of model. So in CFA is basically based on theory. You will have a very sound theoretical backup. In most of the cases, the researcher starts a CFA by constructing certain hypothesis, or at least you may have in your hand a working hypothesis that has not been tested. So when you are talking about the working hypothesis, or a theoretical model, or a theoretical framework in your mind, you must be having certain variables, or you must be having certain factors or dimensions or construct which are basically related to each other. So when we construct the hypothesis, we basically assume that certain variables are related in certain kind of a way, and then we test the entire model. So the basic difference between EFA and CFA lies in the fact that while conducting the EFA, the researcher does not have any understanding about where it will lead. He or she is just exploring and trying to understand what is the nature of that factor structure. And once you know about that factor structure, that forms a part of your theory, by which you can create a theoretical framework or a theoretical model which can be carried forward for the conductance of a confirmatory factor analysis. So there lies the difference. CFA, basically, which we will be studying today, is based on theory. So when we will take an example today, we will be taking a very popular theory in social science, and then we will try to understand how this particular theory holds good, whether it holds good based on a given data set, or whether the data set is incapable to confirm that this particular model is not robust, or it's not good. So the steps in the confirmatory factor analysis, the first step is to define the individual construct of the measurement model. Now you will come across two things, two concepts. One is called the measurement model, and the second one is called the structural model. Now the measurement model is basically the model by which we generally want to test whether the observed variables or the manifested variables are basically converging into a latent construct, or whether the observed variables or the manifested variables can clearly explain or can be a part of a latent construct. A latent construct is a construct which is unmanifested, or we can say, in other words, a latent construct is a construct which cannot be directly measured. Okay, yesterday we gave an example that some of the behavioral pattern of human beings, or some of the personality traits of the human beings, are very difficult to measure directly. There has to be certain kind of a surrogation. There can be certain kind of a proxy representation of those kind of behavioral pattern. So yesterday we talked about introvertness or extrovertness. We can say that perception of service quality. Yesterday we also took that example. These are some of the factors, these are some of the dimensions, these are some of the constructs which cannot be directly measured. You cannot directly measure the introvertness. There has to be certain observed phenomena based on which we can conclude with, okay, this particular person is an introvert person, or this particular person is an extrovert person. So in the measurement model, we are trying to assess whether a set of variable can actually explain or can actually elaborate a particular, or can actually talk about a particular latent construct, or sometimes if the model changes, whether a particular latent construct can be attributed for latent construct is responsible for the manifestation of certain observed variables. So it can be either way around. Some of the observed variables can be attributed for the latent construct, or the latent construct can have a role to play in influencing a set of observed variables. So when we are actually focusing on the measurement model, we are trying to justify whether a set of observed variables are really connected to a latent construct or not. The nature of the connection, that means which is influencing what and which can be attributed to what, it will depend on what kind of model has been formed, whether it is a reflective model or whether it is a formative model. The second step is to specify the overall model to be tested. So the overall model means the entire layout of the model with all the error variances and the covariances, etc., is to be drawn out before we proceed or we take the help of the software for testing. Then estimation of the empirical results of the measurement model. There are a number of we say goodness of fit indices, like the goodness of GFI, the goodness of fit indices, AGFI, the adjusted goodness of fit indices, the CFI, the normed fit indices. There are a number of fit indices that we will see. And side by side, we also have the badness of fit indices, the indices which reflect the lower value of these indices reflect that the measurement model is quite valid, like the root mean square error approximation, the RMACA or the RMR values. These are basically the badness of fit indices. So lower the values of these fit indices, the greater will be the robustness, or the you can say the robustness or the acceptability of the measurement model. And the last one is assessing the validity of the measurement model. As we have stated at the beginning of this particular session, that certain validity has to be established. For example, the discriminant validity, the convergent validity, the nomological validity, the face validity, these validities are to be established to accept the measurement model. So these are the steps in the confirmatory factor analysis. You first design that entire measurement model, both the manifested variable or the observed variable and the latent construct or the construct that is to be measured actually. Then specify the entire layout of that measurement model, then go for the estimation, test the goodness of fit indices, and then last of all you check the validity of the measurement model. So these are the fundamental steps of the confirmatory factor analysis. Now as we have understood that there can be certain kind of model, okay, so since we talked about you know reflective model and formative model. To start with, let us understand two very peculiar form of model. One is called a congeneric model, and the second one is a non-congeneric model. So congenericity and non-congenericity, which one is desirable and what circumstances it takes place, and what does it imply, and which one is acceptable and which one is to be discarded. So before going into which one is to be accepted, which one is to be discarded, or which one is not encouraged to have in your model structure, let us understand the fundamental issues involved with congeneric model and a non-congeneric model. Now you say, in case of a congeneric measurement, as you can see, the underlying principle is there should be one variable for one construct. Okay, so over here you will find just okay, over here you will see that there is one particular observed variable x3. For this particularly, this is a latent construct which cannot be directly measured. Okay, so this is one latent construct. This is another latent construct. Fine. Now, for this latent construct, we have three observed variables. So the data that a researcher is supposed to generate is with the help of these three variables. So x1, x2, and x3, these three are observed variables. They are supposed to define this particular construct. Okay. Now, you see, if it is a congeneric measurement, then one particular observed variable should be responsible to define one particular construct. It is not like that x3 will have a direct connection with this latent construct, and then it will have a connection with this construct also. Okay, so this is undesirable. So one particular observed variable should be attributed to or should be assigned to one particular latent construct. So in a congeneric measurement, it's one variable, one construct. So we have the definite factor loadings, and then we have the error variances. Now the error variance basically are the proportion of variance that do not covary with the latent factors or dimensions. We will come to these error variances and error covariances also. The error covariance basically refer to the error variance that covary. Okay, now what will be the implication of these error variance? We will come little late. We will just follow this particular discussion. So again, explaining the congeneric measurement from this particular point of view, that how the latent construct and how the observed variables are interrelated with each other. We said that in a congeneric measurement, the observed variables, a specific observed variable shall be assigned to a specific latent construct. So there is no question of cross loading. Okay, so a particular observed variable cannot be assigned to two different latent construct. Okay, now there are exceptions also. We will talk from very practical point of view where this non-congenericity comes to play. Now if we see the non-congeneric measurement, you see this is a latent construct. Again, we have two latent construct. This is latent construct 1, and this is latent construct 2. Just okay, so this is L1 and this is L2. Now you see, as we have said during explanation of the congeneric measurement, that a particular variable shall be assigned to a particular construct only. But here you see this x2 observed variable is assigned to latent factor 1 as well as to the latent factor 2. Okay, and as a result of which you will find correlated error variance over here. This is desirable, and this will take place automatically. The error covariance within this particular construct. But when there is a correlated error variance taking place, it brings a lot of ambiguity in the model. Now, if you ask me this question, what is the issue with a non-congeneric measurement? It will be very difficult for the researcher to make an actual interpretation that this particular observed variable under which latent construct it will be placed. And the researcher will be in a dilemma to actually draw out the resultant model. Let me just give you a very practical example so that you will understand. This particular example will also be used in explaining the the formative and the reflective model. Say we want to measure, or we want to have an understanding of a latent variable or about a latent construct, and say the latent construct is, say, viral infection. Okay. Now, it is very difficult to have a direct measure of the viral infection. So we have to depend on a number of symptoms, isn't it? So they say high fever is a symptom, say headache is a symptom. Now, these are the observed variables that a researcher has basically taken into account to have an understanding about the viral infection. So fever and headache and cough and say body ache, okay, and say he or she has taken two more things, say stress or tiredness. Okay, this is one of the variable. And then say another two variable this researcher has taken. One is called, say, dry mouth, and the last one is, say, numbness in fingertips. Fine. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 observed variables, and the researcher is actually interested to measure the intensity of viral infection. Okay, so you can easily have a measure of fever, the intensity of the headache based on certain scale, and you are obtaining these figures from a set of patients, or you have visited a hospital and you have interviewed, say, 100 patients, and you have data with regard to this. Okay. Fine. Now, when you have measured the model, you have seen you will have certain, suppose over here, if I come here, you see when the measurement will be conducted. Yesterday when we saw the measurement, when we conducted the factor analysis, we have seen that from variable 1 to variable 2, variable 3, up to variable n, they can be assigned to certain components or factors. Suppose n is equal to 8. Okay, so it will be up to variable 8, and these 8 variables are assigned to two different factors. Okay, two different underlying factors. So basically there will be certain factor loading, say 0.67, 0.71. So yesterday we told, or yesterday we discussed that there has to be unidimensionality. So one particular figure has to be suppressed. So there are several ways with the help of which we can eliminate and make one variable assigned to a particular latent construct so that the unidimensionality is maintained. Now, what are these things? What are these outputs that we are getting in terms of factor loading? This is called the lambda score. So lambda basically represents the factor loadings. Factor loadings are the correlational values between the variable and the factors, or the latent construct. Okay. Now, if we come back to here, there will be, see, variable 1, variable 2, up to variable 8. So there has to be a certain lambda 1, lambda 2, lambda 3, lambda 4, lambda 5, lambda 6, lambda 7, and lambda 8. So there has to be 8 factor loadings. And say the researcher has found that lambda 1 is 0.79, lambda 2 is 0.71, lambda 3 is 0.69, lambda 4 is 0.82, lambda 5 is 0.71, lambda 6 is 0.65, lambda 7 is, say, 0.12, and lambda 8 is, say, 0.08. Now, what does this suggest? If you see the factor loadings, yesterday we discussed that the factor loadings which are greater than 0.6 are basically emphasizing that there is a very good convergence between the observed variable and the latent construct that it tries to measure. Okay, so anything above 0.6. So if your variable set is quite high here, as an example, as a very small example, our variable number of variable is only 8. But if you are having 80 number of variables, you can take this benchmark to, say, greater than 0.7. the minimum requirement is it should be greater than zero point 0.6. But if you have a large data set or large set of observed variable, you can increase this benchmark of accepted factor loading to zero point 0.7. I have seen researchers who have taken it up to 0.75 also. So all those values which are less than 0.75 will be automatically suppressed, and those factors will not be considered in the entire model. Those factors will be discarded. Now, in this case, say the researcher has set a benchmark factor loading of zero point 0.6. Now, if this is the benchmark, that means any lambda value which is less than zero point 0.6 will not be accepted. Fine. So if any lambda value which is less than zero point 0.6 is not accepted, then look at variable number 7 and variable number 8. Variable number 7 is 0.12 and variable number 8 is having a lambda value of 0.08. So obviously these two will be discarded. Now the researcher will go back and analyze the observed variables that he or she considered as a indirect measure of the intensity of the viral infection. And he saw, or she saw that dry mouth and numbness in the fingertips may not be an actual measure for the intensity of the viral infection. Say, if there is a second latent construct which is talking about, say, diabetic condition or any other immunological disorder, probably that researcher would have found that these variables 7 and 8 would have a very high loading on these two, in this particular latent construct. So dry mouth probably would have scored high. This numbness in the fingertips could have scored high. So the researcher could have got a very non-congeneric kind of a model whereby these two variables are loaded in a specific, latent construct with a lesser degree of lambda value or a lesser value of lambda, and in another construct with a high lambda value or high factor loading. Now, if you have a small lambda value, that means a loading value is, if it is small, then you will find the corresponding error variance value to be very high. Okay, the error terms will be very high. Now, what does this signify, or what signal it gives to the researcher? It gives a very prima facie signal, because there will be certain other tests also. You can check the correlation factor, you can go for anti-image matrix, or you can check the commonalities, okay, how it is influencing the variance being extracted. So there are other areas examining which you can be, a researcher can be doubly confirmed, but it gives a very prima facie indication that if you are trying to identify a set of variables, observed variables, that will have a good measure of the intensity of the viral infection, probably these two variables, variable number 7 and variable number 8, is a misfit or are misfit in the list of variables that has been identified earlier. So to make your model almost error free, because these two variables will have a very high error term, as a result you will find if the factor loading is considerably low, the error terms or the error variances will be very high. So it is better to discard these two observed variables from your measurement model to make the measurement model more robust. Okay, so non-congenericity is basically not encouraged. This kind of non-congeneric measurement is not encouraged, where there will be cross loading, where there will be correlated error variances, etc. These are not encouraged. So to have a very good measurement model, the model should be congeneric in nature. But in practical applications, particularly in the medical field, we know these days the medical science use a lot of SPSS for analysis of the patient data, clinical results, etc. A lot of application of SPSS and high order analytics is used. So a number of researchers came forward and said that a particular observed variable can be attributed to 2 or 3 different kind of latent construct, or for 2 or 3 different kind of diseases. So if it is a fever, it can have a direct bearing for a viral infection. It can have a direct bearing for a bacterial infection. It can have a direct bearing for a fungal infection. So in medical science, when we have practical application of this kind of measurement model, of late we have seen certain journal papers which are actually endorsing non-congenericity of the measurement model, and they are justifying it or logically supporting with this kind of you know cross-loading symptoms for different kind of medical conditions. Okay, so in general, actually, when as a researcher of the social science, we normally accept the congeneric measurement for the measurement model. So we stick with this, that one particular observed variable should be attributed to a one particular latent construct, or should be assigned to a one particular latent construct. Now, having understood the congeneric and non-congeneric measurement, you must ask a question over here, which is very important. Conceptually, this has to be cleared also. Say, for example, this particular construct, we are measuring a latent construct. Okay, so in the confirmatory factor analysis, we are basically measuring a latent construct. So how many observed variables should be there, or how many observed variables should be considered to have a proper measure of the latent construct? That means, what is the minimum number of observed variables to have a good measure of the latent construct? Is it 4? Is it 3? Is it 2? Is it 5? Is it 6? How many observed variables we require? Because a particular researcher has to deal with these observed variables only. So if this particular researcher is having at the back of the mind, when the researcher is starting the research, and he or she is interested to apply factor analysis, say, before applying for the factor analysis, he or she should have a certain kind of idea, certain preconceived notion, or a rough idea that how many factors he or she is looking for. Say this particular researcher is dealing with, say, 50 observed variables, and probably in the back of his mind, he or she is thinking that it could extract 5 factors. Okay, again, these are not rough guesses, because you have a very good literature support, literature review, to understand that ultimately how many factors or how many dimensions will be extracted. There may be certain additional factorization or additional dimension that can be incorporated, which has to be nomenclated or named by you. But initially, you may have certain understanding or certain assumption that this many factors can be extracted out of these 50 observed variables. Now, the question is, if there are 5 construct, and if there is, say, for example, 20 variables, then what will be the minimum number of variables required to adequately justify the measurement of a latent construct? Is there any formula? Is there any rule of thumb? Or is there any normal practice? Is there any references which has been cited in number of good journal papers? So what actually should be the number of observed variables to perfectly define a latent construct? So in this case, there can be 3 different kind of models. Okay, 3 different kind of models based on the number of observed variables that is considered for measuring a latent construct or a hidden construct or unmanifested construct. What are these 3 different models? One is called the under-identified model. The second one is the just identified model. And the third one is the over-identified model. So over here, you can see it is clearly written. The fundamental question that we are trying to explore is how many items or variables should define a construct. This is very important, okay, because it has certain very serious implication for the researchers, for the robustness of the model, or the validity of the model, or the acceptability of the model, or when you will be using that measurement model, and you will proceed one step further to conduct any kind of a dependence analysis. This will be very important. So what is an under identified model, what is a just identified model, and what is an over identified model? So let us have an understanding about this. So look at this particular, measurement. There is, this is the latent construct L1. For this particular latent construct, there are two observed variables. Say it is written over here A1 and A2. So you can say it V1 and V2. Two observed variables are there. So how many parameters are to be estimated in this measurement? Two factor loadings, lambda 1 and lambda 2, and two error variances, E1 and E2. So the number of parameters to be estimated is equal to 4. Lambda 1, lambda 2, two factor loadings, and two error variances, 1, 2, 3, 4. Now, if we see the symmetric variance covariance matrix, so if we see the correlation A1 with A1, you will get a figure. A1 A2 with A1, you get a figure, and A2 with A2, you'll get a this is the distribution of variance covariance matrix. So how many terms we are actually getting? We are getting 3 terms. Okay, so A1 with interaction between A1 with A1, interaction between A2 and A1, and interaction between A2 and A2. So the number of variance covariance term via this matrix we are getting is 3. Now the rule is, if I want to get a very good kind of measurement model, by considering that how many observed variables should be there for a given latent constructs which is to be measured. See, the number of parameters to be measured should be less than the number of variance covariance term. So in this case, you see the number of parameters is greater than that of the number of variance covariance term, and this is not at all accepted. This is an under identified model. So if you have a model whereby there is a latent construct which is only explained by, or only attributed by, or it is influencing only two observed variables, that is basically an under identified model, which is not a good model at all. It is not a robust model. It cannot be generalized. It cannot be used for further dependence technique. Okay, so two variables, two observed variables for a latent construct, this kind of a model should be discarded. So again, I'm just giving you the general rule that is accepted, that the number of parameters to be tested should be lesser than the number of variance covariance term that is coming out of that symmetric covariance matrix. So now let us increase this observed variable by a single number. So you see there is a construct L1, and now we have 3 observed variables. So let us have this construct as L1, 3 observed variable V1, V2, V3, or A1, A2, A3. So how many parameters are to be estimated? Lambda 1, lambda 2, lambda 3, 3 factor loadings, and 3 error variances. So the number of parameter is 6. And see the symmetric covariance matrix. We want to identify the variance covariance term. So A1 with A1, we get a term. A2 with A1, we get a term. A3 with A1, we get a term. A2 with A2, A3 with A2, and A3 with A3. So number of parameter over here is equal to the number of variance covariance term. Now, this is a just identified model. It is acceptable, but it is a just identified model. You can have this kind of a measurement structure in your measurement model. It is acceptable. It is not that it should be discarded, but now you have realized that the number of observed variable to actually define a latent construct should be having a minimum of 3. Okay, and what is the desirable thing? Or every time we may not end up with this desirable kind of position, but we can, if we are very thorough with our literature survey, we can actually identify some of the models, some of the observed variables with greater number, which will be very much sufficient to properly justify a latent construct. So over here you see, for this for this L1 latent construct, there are 4 observed variables, so the number of parameters to be estimated is 8. Okay, and now if you come to the symmetric covariance matrix, you will find that the number of variance covariance term that it is churning out is 1 2 3 4 3 7 9 10. So here the number of parameter is less than the number of variance covariance term. So this is the ideal kind of a scenario, ideal kind of a measurement construct that every researcher should pursue for. So if there is a very general question that how many variables, observed variables, are to be considered to define a single latent construct or to conceptualize a single latent construct, it is always desirable that the minimum number of observed variables should be 4. So there are many journal papers. If you go through journal papers in the internet, or if you examine through many databases, you will find there are many factor analysis being done: confirmatory factor analysis, exploratory factor analysis. Ultimately it has churned out a 2 observed variable factor structure. You see, unfortunately, what will happen if you put these things into a statistical process, it will churn out certain results which can have significant value. But overall, the model, if you have only 2 variables which is explaining a latent construct, it will not be a very good model. Although you may have statistical concurrence, you may have statistical support, which may be significant. Okay, but all the significant statistical concurrence do not conform a robust model. So if you want to have that particular model in mind, which will be very robust, which will be very dynamic, and it can be applied across a different context, across different perspective, the minimum number of observed variables to define a particular latent construct, or to have a measure of a particular latent construct, should be 4. So that's basically is the number that we are looking for. Now we want to look at one particular issue, that is the 2 different kinds of model that we normally test in confirmatory factor analysis. One is called the reflective model. The second one is called the formative model. So what is the exact difference between the reflective model and the formative model? Now let us take our old example that we took a few slide back, that viral attack. Okay, now over here you see the viral attack is basically our latent construct, and we should have a measure of this latent construct. Okay, and now what are the observed variables that are visible in a patient or in a human being? That a particular person is suffering from fever and chill. Side by side, he is also suffering from headache, and he is also having a cough, and he is also stressed up, or feeling a fatigueness, or being tired very easily. And then we can have the measure of this viral attack. Now, why it is called a reflective model? It is very important to note in which direction these arrows are moving. It is moving from the latent construct to the observed variable. What does it signify? It signifies that here the latent construct is basically the independent kind of a variable. Okay, independent variable means this, basically the latent construct is the influencer. Under the influence of a viral attack, the particular person will have fever and chill and headache and cough and tiring. And one interesting thing will be, there will be a high degree of correlation between these observed variables. So fever and chill, along with headache, along with cough, along with fatigueness, etc., will give you a direct interpretation or direct conclusion that this person must have a viral attack or suffering from a viral disease. So under a reflective model, the latent factor is basically the independent one, and the observed variables are basically the dependent one. So exactly opposite thing takes place when we take formative model into consideration. You see, in the formative model, again you see the arrow direction. This is the latent factor, heart attack, and these are the observed variables. You see the arrow direction from the observed variable to the latent variable. So over here, these observed variables are the independent factors. So alcohol can be one of the causes for a heart attack. Emotional stress can be one of the causes for heart attack. Diabetes can one of the causes for heart attack. Smoking can be one of the causes of heart attack. And interestingly, see, these variables, so observed variables, which are independent in status, they may not share any intercorrelationship between each other. So it's very difficult to find any significant correlation between alcohol and emotional stress, or emotional stress and diabetes, or diabetes and smoking. So but we can actually interpret where, if the heart attack is taking place as a result of these observed variables. Okay, so heart attack can be actually attributed to the overconsumption of alcohol, or overstressed condition, or a diabetic condition, or if a person is a prolific smoker, leading to a cardiovascular issue. So this is a formative model. Now, one issue with SPSS that we often face, that SPSS actually fails to measure a formative model, particularly when we talk about the normal SPSS that we used yesterday, the SPSS basic or the fundamental software, as well as the SPSS AMOS, so which is supposed to conduct the confirmatory factor analysis. Both these platform are very good platform. Not the first one, not the basic one, but AMOS is a very good platform where the reflective kind of models can be taken up. Reflective models, not the formative models. So if you ask what is that particular software or application tool which can take up both the reflective models as well as the formative models, the formative models can be best done by using the smart PLS tool. Okay, both the reflective model can also be done by smart PLS tool, and the formative models can be adequately answered by the smart PLS tool, particularly when you are going one step ahead and conducting the structural equation modeling. Either it is a CB based, that means covariance based structural equation modeling, or non-covariance based structural equation modeling. Smart PLS does it wonderfully well. There is another software which is called the Adanco. Adanco has a very good facility that it conducts EFA and CFA simultaneously. So you need not have to take up EFA and then followed it up with CFA, as it happens in the case of SPSS. First you do the EFA using the normal SPSS platform, and then you take up the AMOS platform to conduct the CFA. So you require two different platforms, although both belong to the SPSS family or the IBM family, but you require two different platforms to conduct these two. And you cannot conduct it simultaneously. But at Adunco, it gives you that particular benefit or facility. The moment you are conducting EFA, the CFA is also done at the back end. Although the structural model can be taken up at a later stage. So these are the few issues with the measurement model that we are looking forward. So we have understood the congenericity and the non-congenericity. What is a congeneric model and what is a non-congeneric model, and which one is desirable. We have also understood that how many observed variables are to be there ideally to have a proper measure of a latent construct or an latent means hidden construct or an unobserved factor. And then we have understood what are the differences between the formative model and the reflective model. And now we talk about certain issues with regard to the measurement model or estimation of the empirical results of the measurement model. So when we go for the model identification, we focus on two things. One is called the order condition and the second one is the rank condition. So in the order condition, we basically look forward to the unique variance and covariance, which should be greater than the number of parameters to be estimated. That we have already stated, isn't it? In the over identified model, the number of variance covariance term is greater than the number of parameters to be estimated. So if the order condition has to be valid, then obviously we must have a over identified model. And the rank condition says that there should be minimum 4 items per construct. So that also we have seen that if a rank condition has to be valid, then there must be at least 4 items. That means 4 observed variables for a particular latent construct. If we are having the minimum number of 4 items for a particular latent construct to be measured, then automatically the order condition will be fulfilled. The second one is the assessing the validity of the measurement model. We normally focuses on the fit indices that I have told you, the GFI, the goodness of fit indices. There are a number of fit indices. There is GFI, GFI, NFI, CFI, the Tucker-Lewis index, non-normed index, NNI. A lot of indices are there which can give you a certain idea whether the measurement model holds good or not. And then if you surf the internet, you will find all the references, or you can say what is the benchmark when you can say that the goodness of it is good. Goodness of it is having an acceptable value. So anything over any value over a 0.9, 0.900 or any value over 0.9 for any of these goodness of fit indices is considered to be the robustness for a given measurement model. So a measurement model to be understood as a good one, a robust one, to have a proper measure of the latent construct, the goodness of fit indices must cross the value of 0.9. So it is 0.9 or more. The incremental fit indices, the parsimonious fit measures, etc., are also to be considered to assess the validity of the measurement model. At the same time, as I have told you, there are certain indices which are called the badness of fit indices, like the RMSEA or the RMR. And higher the value of GFI, better will be the measurement model. Lower the value of badness of fit indices, better will be the measurement model. So the RMSEA value and the RMR value should not exceed, say, 0.05 or 0.04. So any RMSEA value or RMR value close to 0.04, close to 0.05 is indicative of a good measurement model. Then the estimation of the empirical results of the measurement model. To continue with that, we already talked about the construct validity. The construct validity, it is supported by 3 specific measures of validity. The first one is the convergent validity. We will see every validity, we will explain when we take on the hands-on. So the first one is the convergent validity. Now, convergent validity is established by virtue of three issues. One is the factor loading should be greater than 0.7. The second one is the average variance extracted should be greater than 0.5, and the construct reliability should be greater than 0.7. So there are three values which will be indicative of the convergent validity. So in your journal paper, when you will be representing these values in the tabular form, you will just quote that since the factor loading is greater than 0.7, since the average variance extracted or the AVE value is greater than 0.5, and since the construct reliability is greater than 0.7, we conclude that the convergent validity is established for this particular measurement model. Similarly, in case of discriminant validity, which is again a very good measure of the robustness of a model, or the the model to be well accepted, the average variance extracted between any two constructs should be greater than the sum of the squared correlation between the two constructs. Now, you see, you can do it manually. The convergent validity you can find out manually, particularly the average variance extract or the construct reliability. These two can be computed manually. Even the discriminant validity can be computed manually, but we have certain packages, computing packages, which has made our life very easy. Nomenological and face validity. Nomenological, basically, it's a network validity. Once you take this particular CFA and you extend it to the structural equation modeling, probably you require that nomenological or networking validity. Face validity basically is the content validity. Content validity means whether you have properly identified all the variables which actually give a good measure of the latent construct. Okay. Now, if you have to discard too many variables from the ultimate scale, it is not good to confirm the face validity. Face validity is almost like a content validity. So the initial content or the initial scale items that you are drawing, yes, there may be certain scale items which may score very poorly on the factor loading and whose error variances will be very high. You may have to delete those delete those observed variables from the ultimate measurement scale. But your phase validity will be established if your content is undergoing minimum rejection. So that minimum rejection criteria establishes the phase validity. And let us now move to the hands-on. With this amount of understanding of the CFA, and all the explanations will be done once this hands-on session is conducted. So we have already said, say, if we start from the first slide, in the very first slide, we had an understanding that CFA is basically based on a theory, an existing theory, or an existing working hypothesis, or a hypothesis constructed by the researcher himself or herself, or a kind of theoretical framework, or a default theoretical model based on the literature review, identification of certain factors, and the manner in which they are intercorrelated with each other. Based on all those things, the CFA will be taken up. So in this particular example, I have taken up a very important theory in social science and consumer behavior. It's called the theory of planned behavior. Initially, the theory was introduced by Fishben and Eisen in the year 1980. The initial theory was called the theory of reasoned action. So initially, it had a different name altogether. But in the year 1985, these researchers introduced a new factor in this particular theory, as a result of which the entire structural concept changed, and the theory was renamed as theory of planned behavior. So from the theory of reasoned action, it was converted to theory of planned behavior. And this particular theory of planned behavior, it has 5 major constructs or 5 major factors. What are these 5 major factors? The first factor is called the attitude. The second factor is called the subjective norm. The third factor is called perceived behavioral control. The fourth factor is called the purchase intention. And the fifth factor is known as the purchase behavior. Okay, so when I refer to the fact that initially in 1980, when this theory was proposed as theory of reasoned action by the same 2 researchers, this number 3 construct was not there in the initial theory. So perceived behavioral control, this particular factor, was not introduced in the initial theory. But in 1985, from between 1980 to 1984, Fishman and Eisen, they use this theory of reasoned action in several behavioral study, consumer behavioral study, with regard to how they frame purchase behavior, how they take purchase decision, how the intention is formed, and what are the exact output of the purchase behavior. And they found that something was missing. So they redefined this particular theory and found a new construct or a new particular factor, which is called the perceived behavioral control, that adequately explains, along with the attitude and subjective norm, the purchase intention and the purchase behavior. So the researcher who is actually conceiving confirmatory factor analysis is taking this particular existing theory of planned behavior, and this researcher is also having a kind of a theoretical framework which says that attitude, subjective norm, and perceived behavioral control, they are actually influencing this purchase intention, which in turn is influencing or impacting the purchase behavior. So this is the default theoretical model that this researcher is having in mind. And first of all, we will test the measurement model. The measurement model means the measurement for all. These are all the latent constructs, because we cannot have a direct measurement of attitude. As I have told you, all these psychographical variables or behavioral pattern cannot be directly measured. So attitude of a particular customer or subjective norm which is governing the purchase intention, the perceived behavioral control, the purchase intention of a particular consumer, the purchase behavior, output behavior of a consumer, these cannot be directly measured. So these are all the latent constructs or the latent factors. So at the very beginning of the study, if a particular researcher is using this particular theoretical framework, he or she is ready to conduct a confirmatory factor analysis. But perhaps to start with, this particular researcher will go for an EFA to check the measurement model, followed by CFA to understand the validity of this measurement model, followed by SEM, the structural equation modeling, to have an understanding about this theoretical structure or these theoretical factors. So we have 3 issues in our hand. First of all, we need to test the measurement model. The second, we need to validate the measurement model. And third, we need to justify and test the structure. So EFA will be done to have measurement to test the measurement model. CFA will be done to validate the structure, and SEM. Now in the AMOS, the EFA and CFA can be taken up together. So the measurement model can be tested and validated simultaneously. So we will go for use of the AMOS. Now, as I have told you that these five are the factors or the latent constructs or the hidden constructs. So there must be certain observed variables. Now, how these attitude is measured? So how many variables are there that measures attitude? How many variables are there that measures subjective norm? How many variables are there that measures the perceived behavioral control? Now, this entire case study is taken up to have an understanding of the consumer with their purchase intention and purchase behavior with regard to environmental friendly products, which we call green products. Okay, so what the consumers purchase intention, how it is governed, how it is framed, and what are the purchase behavior that are manifested when it comes to make decision and make intentions about purchasing green products or eco-friendly products. So that is basically the case study. Now, if you see the observed variables that will measure all these constructs, so let us take one by one. See, attitude, it is basically measured with these four items. So there is a statement, and then there is a 1 to 7 scale, 1 being not at all agreed, least agreeableness, and totally agreed, the 7. So I think that purchasing green product is favorable. So either you may not agree with the statement at all, so in that case you will have 1 or 7. So there are many intermediary scores, say somewhat disagreed or somewhat agreed, then neither agreed, neither did agreed, agreed, etc. So it's a 1 to 7 Likert scale the researcher has used. Now, interestingly, this attitude as a latent construct, it has actually 4 observed variables. Say it is 81, 82, 83, and this is 84. And if we come to subjective norm is having 3. And you will remember that when we are taking only 3 observed variables to define a latent construct, we are actually using a just identified model, isn't it? So we have these subjective norms. So subjective norms, we can say SN1, SN2, SN3. Then in case of perceived behavioral control, as a latent factor, we are using 4 observed variables. So this is also a over-identified model, 4 variables. So PBC1, PBC2, PBC3, PBC4. Again, we are using a 7-point Likert scale to generate response from the customers who are actually buying green products or who are having some kind of perception about purchasing of the green products. Purchase intention, 3 variables, observed variables. Purchase behavior, 3 observed variables. So this is the entire setup of the you can say the measurement, construct measurement. Now, what is the measurement model? Okay, so the measurement model will be like this. Say, for example, what we are having in our hand, we are having attitude as one of the latent constructs. So attitude is one latent construct, subjective norm is the second one, perceived behavioral control is the third one, purchase intention is the fourth one, and purchase behavior is the fifth one. So latent construct 1, 2, 3, 4, and 5. Okay, so these are all the latent constructs. So for attitude, we have 4 observed variables that we have seen from 81 to 84. In case of subjective norms, we had 3 from SN1 to SN3. For perceived behavioral control, we are having 4. For purchase intention, we are having 3. And for purchase behavior, we are having 3. So how many observed variables are there? 4 plus 3, 7 plus 4, 11 plus 3, 14 plus 3. So there are 17 observed variables. Okay. And how many error terms will be there? Since these are all independent variables, there has to be there will be certain error terms. So E1, E2, E3, E4, E5. Okay, so this is basically our measurement model, and then we need to draw the covariances between this latent construct. Okay, covariances between these latent constructs. So this is the entire measurement model that we need to draw out on the software platform, and then we need to execute the study. Okay, so this is the measurement model, and let me go here. This is the structural model. So the basic difference between the measurement model and the structural model is the measurement model will only give the idea of whether all the variables are adequate enough to give a proper measurement or proper understanding about the latent construct. So the measurement model only focuses on the measurement of the latent constructs, whether all the observed variables that we have used are enough to have an understanding of the latent construct. So the measurement model is this one, and the measurement model will be followed by the assessment of the structural model. In case of a structural model, what we are examining, we are examining the way the latent constructs are intercorrelated with each other, or how they are related to each other. Is it a kind of dependent independent kind of relationship, and if it is that kind of a relationship, which one is the dependent on which particular latent construct, etc., or whether there are certain intervening effects also, if certain latent construct are working as a mediator or a moderator in this entire relationship structure or not. So once we confirm about the measurement model, that means once our latent constructs are adequately represented by the observed variable, then we can take up those latent construct and try to analyze the structural pattern that we have identified as a theoretical framework to start with. The researcher have started with this particular theoretical framework, but initially he or she has to test the measurement model to check whether the latent constructs are properly measured by the set of observed variables that has been considered by the researcher. So now we need to progress towards the platform of AMOS. So let us open these AMOS graphics. This is also an IBM tool. So once you open this AMOS, it gives you this kind of an interface. And this is the opening, you can say, window of AMOS. So you have a navigational panel on the left hand side. You have a lot of tabs over here, and these tabs represents, or these tabs are representative of different kinds of functionalities. There is a blank space over here that you can see. This is a working space. So your model will be drawn out over here. Okay, now once the model is drawn out over here, there is a data importer over here. I will show you. It imports the data that you require for testing the model, and then there is a tab which sets the analysis properties. Analysis properties means which things are to be analyzed, and then there is an output viewer. Once you conduct the analysis, there will be definite output, and you need to analyze that output and interpret that output. So this is in very short the outlay of AMOS, and there are various tools which helps you in drawing out the measurement figures. So everything is like that only. So let us start. Now if I will take up these two things simultaneously, both our slide and our AMOS. So over here you see how you have drawn. So all these latent constructs are actually represented either with the help of an elliptical structure or with the help of a circular structure. Okay, so all these subjective things are all these latent construct or unmanifested construct or unobserved factors are represented with an elliptical shape or a round shape. All the observed variables are represented with a square shape or a rectangular shape. All the error variances are represented with the help of small circles. Okay, now let us get back to the drawing. Now to draw this kind of a structure, whereby the latent construct are attached to the observed variable, we have a very unique thing. You can do two things. You can click this elliptical thing, and you can click this elliptical thing and you can draw it out. Okay, and then you have to include the individual, you have to include the individual kind of, as I have told you, the square shapes are basically for the observed variables. This elliptical shape is for the unobserved variables or the latent construct, and these small circles are basically for the error terms. Okay, so either you can do it like this: you draw an elliptical kind of a structure, and then you take this particular thing which takes into consideration the drawing of the observed variables as well as the error term together. Or if you undo this entire thing, you can do one thing which will this particular thing will not be required. Say if we go to a new page, you simply select this particular icon that you are seeing. You simply select this and you simply draw this small circle. Okay, now once you draw this small circle, you take this icon back inside the circle and you click 4 times. You see why I am clicking 4 times? Because the first latent construct attitude is having 4 observed variables. So I have clicked it 4 times and there are 4 observed variables. I told that the
Sir,
square
would you repeat this step? Sir, would you
okay,
repeat this step?
yes, yes, yes. Let me open up a new file. See, in the very upper row of this navigational panel, there are 3 tools, or there are 3 tabs. So individually, you can use this square to draw a square shape. Individually, you can use this ellipse to draw an elliptical shape. Or you can simply use this particular tab, this particular icon. If you click this icon, you can use it. You simply have to press your cursor and you have to draw a circle, a small circle. It will be automatically drawn, and then you take back this particular icon inside the circle, and you need to click as many times as you need the number of observed variables. Okay, so you go back to our normal model. For attitude, we have 1, 2, 3, 4 variables. So obviously I need 4 observed variables over here, so I need to click only 4 times. So 1, 2, 3, 4. So I have, as I have told you, this square, this round or ellipse, it represents the latent construct. The square or rectangles, it represents the observed variables. And I will show you, it has gone beyond this particular page. There are small circular shape over here which represents the error term. Now you see your entire drawing has crossed the page limit. How to bring it back, how to resize it, etc. What you can do is you go here. There is, you can see my cursor is hovering around this particular symbol on the left hand side. 1, 2, 3, 4, 5. This is the 6th row. In the 6th row, there is almost a circle like thing which indicates rotate the indicators of the latent variable. So if I select this If I come back to the picture, I will simply click and it will rotate. Okay. Now, the rotation, let me make a very convenient arrangement of this. So let us keep it like this. So over here, you can understand this will represent our latent variable. 1, 2, 3, 4. This will be the observed variable for the latent variable, latent construct attitude. And these are the 4 error terms associated with this 4 observed variable. Now, you see, a part of this drawing is still outside the page. So I need to bring everything within this white page to conduct the analysis. So what you can do is you come to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th row. 10th row, in this particular column, there is a flower like structure. You just click the flower like structure and just allow it to remain selected throughout the process of confirmatory factor analysis. What it will do, it will help you to identify the entire group at a time. So if you want to move, if you want to shift, if you want to modify something, the entire thing will be selected at a particular point of time. So you just preserve the symmetry column, preserve the symmetry tab. You click the preserve the symmetry tab, and then, as I've told you, a part of this particular structure has gone beyond the page limit. I want to drag it slightly on the right hand side so that the entire thing comes to my white page. So what I need to do, there is a truck like structure over here. You can see a red truck like structure, so representing transportation and movement. So I click it and simply I drag it. Okay. Now I can also drag these things so that it can be nicely formed, it can be nicely shaped. uh, you can put it as per your convenience. So you select it and you drag it. So what I have done is I have clicked this preserve symmetries, this particular tab, and then I have used this struct to make these shift. Okay. Now, the first latent construct has been drawn. So I need to draw the second construct. So you deselect this truck and go again to this one to have the second construct being drawn. The second construct is the subjective norm, and the subjective norm has 3 observed variables. So I click here 3 times. Again, I go to this particular rotate the indicators of a latent variable tab, and I rotate it. Okay, so once I rotate it, I deselect it, and I going to go to my truck once again, and I use this truck to drag this thing so that it can be nicely placed, it can be nicely arranged. It looks like nice. So the second latent construct has been drawn. Let me deselect the truck, go back to this one, whereby I can draw the third construct. The third construct is the perceived behavioral control. It had 4 observed variables. So 4 times I will click, I will use the rotation, it will be rotated, rotation deselected, I will select the truck and it will move. I will just decrease the space between the observed variable, and then I will reposition this latent variable. It is done. Again, deselecting the truck, going to the fourth construct to be drawn. The fourth construct is purchase intention. It has 3 observed variable. Again, going for the rotation, I am rotating it, deselecting it, selecting the truck. Again, I am positioning this, I am decreasing the space, repositioning it. Now for my final one, final latent construct, that is purchase behavior. It has also 3 observed variables. Let us rotate it. After rotating, I'm going to the truck. Again, decreasing the space between the observed variables, repositioning it. Fine. So the basic structure is drawn. Okay, the basic structure is bringing all the latent constructs, drawing all the latent construct, and connecting the latent construct with the observed variables, connecting the error terms with the observed variables. Now, there is a very important task to do, that is drawing all the covariances between all the latent constructs. So, how we can do that? There is a very simple way to do it. Now, the covariances basically has a double-sided arrow. So, what you can do is you select this double-sided arrow on the navigational bar on the left hand side in the second row itself. You see, this is a double-sided arrow. You can click it and bring it here, and you can draw it manually. Okay, so you can draw it manually. This is one option that you have. So let me undo it. Or there is a second option which will automatically draw all the covariances for you. What you need to do, you come to this 1, 2, 3, 4, the fourth row. In the fourth row, there is in the first column there is this particular tab which says select one object at a time. So you just click it and you select all these latent construct. Now you see, the moment you select it, the peripheral ring turns into blue color. The margin turns into blue color. The blue color suggests that these things are selected, and until and unless you remove this is the sign. At the end of this particular row there is a sign which says deselect all. If you click, it will turn into black color. That means all the things have been deselected. So my objective is to select all the covariances. So let me go there and select. So all the latent construct I am selecting, because I will be drawing the covariances amongst all the latent constructs. So I have selected all the latent construct, and then you go to plugins. Okay, on the upper navigational tool there is a term, there is a tab called plugin. Now under plugins there is a particular terminology called draw covariances. Now you simply click draw covariances. See, all the covariances will be automatically drawn. Now let us make a nice representation of it, because it looks very clumsy. So you come down to row number 1, 2, 3, 4, 5. This is the fifth row in the first column. You see, there is a tab which says change the shape of objects. So you just click it, you select it, and you come and select one of the covariances. And the moment you select it, the moment you bring the cursor on the covariance, it turns into red color. And then you just drag this entire thing. Okay, so it will come to one particular side of the page. Now it looks much better. But again, probably certain arrows, certain covariances are deeply inserted inside the latent variable. Let us make certain cosmetic changes. So there is another tool over here. Okay, this is called a magic wand or a touch-up variable. Touch-up variable means it makes every layout. It makes certain cosmetic changes and it beautifies these layouts. So you select this magic wand or the touch-up thing, and you just click in every observed variable. It never requires to click every unobserved variable. With a single click, you can see these covariances are nicely arranged. Now you deselect this. Now, as I have told you, that it is showing blue lines. That means it has remained selected. I need to unselect or deselect all these things. So I go here and just click this deselect all object, and it will turn black in color. Now my measurement model has been drawn. Okay, this is the fundamental measurement model. You can say I have only draw the skeletal structure or the skeleton of this particular measurement model. It has not been populated with data. So we need to import a data. Okay, so I have a SPSS file uh, which has taken response from 300 customers about that theory of planned behavior model based on those 17 observed variables that we have seen. 17 observed variables means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 observed variables, and I have taken a response from 300 customers. So let us bring that data inside this particular software. So how to bring the data or how to import data? You go to 1, 2, 3, 4, 5, 6, 7, the eighth row, the first column. So over here you will find a tab which says select data file. So you click it and then you go and select file name. You go to the place where your data has been stored. So this is TPB, the theory of planned behavior. Let us open it and just click OK. So the data has been imported. Now, how do you know that the data has been imported? So you go to the third row in third column. See over here, there is a tab which says list variables in data set. Now to observe all the variables, whether the entire data has been brought over here, you just click it. You see, these are the list of variables that has been brought from the data set. Okay. Now I need to populate this particular structure with the data. So what I can do over here, see, this is the first latent construct, which is attitude. And this is 81, 82, 83, 84. So attitude is measured with the help of 4 observed variable. I can directly select 81 from over here and can drag it over here. Now, you see the difficulty. Since I require a very short representation because this is a very small box. But the moment I dragged this 81, the entire statement is dragged over here, and it is not very convenient. It doesn't look nice also. I want only 81. I know, because 81 is a code that has been given by the researcher, and this code represents this particular statement. So what I have to do to insert just the code. So let us undo this particular action. Now, just to have the code in these boxes, you go to this view tab at the top of this particular software panel. You go to this view tab, click it, and you select the first property, which is called the interface properties. You click it. The interface property window opens up, and there are several tabs: page layout, formulas, colors, typefaces, the pen width, miscellaneous, accessibility. You click this miscellaneous tab, okay, and you will find that by default this first one, display variable labels, is checked. So you can uncheck this so that the labels will not be imported, only the code will be imported. You simply apply it and close it. Now you see, if I drag 81, it will only drag the code. Then 82, let me, this is a process, so with the help of which you are now populating this particular structure that you have drawn. So there are 3 observed variable for subjective norm. There are 4 observed variable for perceived behavioral control: PBC1, PBC2, PBC3, and PBC4. There are 3 observed variable for purchase intention: PI1, PI2, and PI3. There are 3 for purchase behavior: PB1, PB2, and PB3. Okay, so all the observed variables are placed. Now I have to specify the unobserved or the latent construct. So just take your cursor inside the latent construct tab, and then just double click it. It will open up a window called object properties, and then just type out Okay, the first one is attitude. So attitude, take the cursor to the second construct, you just click it, and this is subjective norm. Take it to the third one, perceived behavioral control. Take it to the third one, purchase intention. And then the last one, purchase behavior. Okay, so all the latent constructs have been named. Now we have to mention the error term. So it is E1. The first one is E1, E2. We just click and type. It's that easy. E4. This is E5, E6, E7, E8, E9, E10, E11, E12, E13, E14, E15, E16, and E17. So this is finished. Actually, we have populated our measurement model with all the required nomenclature, and the data set has already been imported. Now it's time to analyze. So you can close this window. So you can take a brief look into this particular measurement model. So we have constructed the measurement model. Now we start our analysis. Now for the analysis, we go to the left-hand navigational panel, and the area where my cursor is hovering, this particular tab, which is basically for the analysis properties, you go and click it, and then the first basic estimation type we will select. By default it will remain selected, which is the maximum likelihood model that we will be using. We will be selecting the output, what we require as an output. So minimization history, data reduction technique, because the EFA will take place simultaneously. We will go for the standardized estimates. You can select this second box, and you can go for the factor score weights. Okay, and this time you do not require this indirect and direct and total effects, because you are just measuring the measurement model. The covariance of estimates, it's required. The correlation of estimate is required, and these standard things or these fundamental things are enough to have an understanding of the measurement model. So once you select minimization history, standardized estimates, the factor score weights, the covariances of the estimates, and the correlations of the estimates, you just close it. Now in that same row, there is a third tab which says calculate the estimate. Now the moment you click this calculate the estimate, the software will ask you to save this particular file, because without saving you cannot run this computation or this calculation. So you will see the moment I just click this calculated, it will ask me to save. So let us give a name of this particular file, say theory of planned behavior tpb_1. So I'm saving this on my desktop. So save it. And you see on the right hand bottom corner, there was a very brief kind of process that went on, and the calculation has been done. Okay, now how will you know that the calculation has been executed properly? You see, in this particular pane, there is a particular tab which is, if you bring the cursor, it says the view the output path diagram. Now if it is activated, that means if this red arrow is activated, you will know that the calculation has taken place properly. If the calculation did not take place properly, that means you had certain issues with the with this measurement model. Some mistakes have been done. Say, for example, in your data set, if I bring this data set, say it is 81, isn't it? By mistake, if you have written 80, say, instead of 1, suppose you have written 80L, or say SN3, instead of SN3 you have written SM3, then your computation or calculation will not take place. It's very sensitive to the data set. So the kind of abbreviations that you are using, it should exactly match. So it is better, instead of typing out, you need to drag and drop it. So that will be better. Okay, now since I have seen this red arrow, that means my calculation has taken place properly. Now there are two estimates. One is the unstandardized estimates and one is the standardized estimate. You see in this particular window, small window, there are two estimates. One is a unstandardized, one is a standardized. So if I click the unstandardized estimates, standardized estimates, where it has gone. Okay, so this is the standardized estimate. So you see all the factor loadings are there. All these factor loadings have come up. Okay, and all these covariances are also there. This is the unstandardized estimates. There also you see all the factor loadings, and the covariance estimates are also there. Okay, now if I want to visualize the entire output, that means all the different outputs that this particular measurement model has churned out, or rather I will say all those outputs that will help me to form certain kind of interpretation about my measurement model. Should I consider my measurement model to be valid? Should I consider my measurement model to be robust? Can I go one step further and conduct the structural equation test, etc.? So I need to have an idea about the entire result. So over here, you see on the left hand side, you again come to the navigational panel. The area where my cursor is hovering, you will find over here, if you just bring your cursor here, it says view text. Okay, you just click it, and this entire result window will crop up, and you will have all the results over here. So if you want to have the analysis summary, you will have the variable summary, how many variables are there which are to be estimated. So you have 17 observed variables, and then 5 unobserved constructs, and 17 error variables. So what is the total number of things that are to be estimated? The total number of things that are to be estimated are 17 observed plus 5 latent, that is 22, and 17 error terms, so that is 39. Okay, so if you scroll down, you will find, yes, the number of variables in your model is 39, number of observed variables 17, number of unobserved variable is 22. Why it is 22 unobserved variables? Because there are 17 error terms plus there are 5 latent constructs. So those are all unobserved variables. Number of exogenous variables 22, number of endogenous variables 17. Now the question is, what is the difference between an endogenous variable and an exogenous variable? Endogenous variable is basically the dependent variables. The exogenous variables are basically the independent variables. So all these, error terms as well as these latent constructs are our independent variables, and the observed variables basically are the dependent variables. Remember, this is the concept of the reflective model. Okay, I told you when we discussed about the reflective and the formative model, and one of the limitations of the SPSS platform is it cannot deal with the formative model. Okay, so this is one of the examples of the reflective model that we have taken up, and all the observed variables are basically the endogenous variables. So over here it is clearly written observed endogenous variables. Okay, now if you come further below, you will find the model fit. Okay, but before that we need to go to the estimates. Under estimates we need to check the scalars. In the scalars we will have the regression weight. You can have very good estimation of what, because you have already gone through what regression stands for. Now you will have regression across all the latent construct, the regression relationship, and you'll have the estimate, the standard error, the critical ratio, the significance level, this p level. Triple star means highly significant. So you will have all the regression weights over here. And if you want to have a very refined view, you can go for the standardized regression weight. You can have measures of the covariances. You can have measure of the correlations between several construct, and as well as an estimation of the variance. So uh, like this critical ratio, how you are getting this particular critical ratio? If you divide the estimate with standard error, you will get this individual critical ratio. So 0.937 divided by 0.051, you will get the critical ratio for this particular relationship. Then again, 0.693 divided by 0.034, you will get 20.154 as a critical ratio. Now we are interested in, as I have
স্যার
told you.
স্যার রেজাল্ট গুলো করতে গেলে স্যার রেজাল্ট গুলো কি কমান্ডে বেরোলো?
ও আচ্ছা, দাঁড়াও আমি এটা তাহলে বন্ধ করে দিচ্ছি। You come to 1 2 3 4 5 6 7 8, this ninth row, second column over here. Okay, so in the middle, this middle icon, if you bring your cursor, you will find there that this cursor is talking about view text. Okay, so you just click it and your results will be displayed. And on the left hand side, there is a navigational tree basically, and you can just click it and it will be expanded. So the variable summary, then the estimates, the scalar estimates, the matrices. We basically focus on the scalars, basically the regression weight and all that. Now one of the important issues that we discussed over here regarding regarding concluding or estimation of the validity, we talked about the convergent validity, we talked about the factor loading. So we will have a very quick look into the standardized regression weight. Now if you see the standardized regression weight, except for this perceived behavioral control 3 and a purchase intention 3 and purchase intention 1. Okay, this perceived behavioral control 3, it is having a very poor loading, only 0.334, and purchase intention 3 standardized regression weight is 0.672 and purchase intention 1 is 0.669. Now if we go back to our earlier concept, we said that for convergent validity, the factor loading should be greater than 0.7. So in this case, these three observed variables are violating this particular norm, particularly the perceived behavioral control 3. So we can actually remove this particular observed variable from our final measurement model, because if we retain this, although this is significant, I'm not saying this is not significant, but in the context of validity of the measurement scale, this particular observed variable, if it is retained in the scale, then probably it will disturb the overall quality of the scale. It's better to remove it. So the next time when we will be conducting an individual or independent study using the same scale, because now you are actually validating a scale. Once you have validated the scale, you can use the scale for further study, the refined scale or the finalized scale for the final, for any other kind of a study. So it's better to remove this PBC3. It is better to remove PI3 0.672, close to 7, but since it is lower than 7, let us remove it. Now one more thing that will come over here is, if I retain 0.672 and 0.669, to what extent it will disturb my structural equation that I need to test. See, if I remove pi3 and pi1, the purchase intention will have only one observed variable, and it will become a very poorly under identified structure. So there is a dilemma for the researcher whether to delete purchase intention 3 and purchase intention 1, which is just below 0.7 level. So for the time being, you can retain these two variable, but definitely you have to remove this perceived behavioral control 3, which is having a very poor loading, 0.334. Now let us go to the second one. The average variance extracted is 0.5, should be greater than 0.5, and the construct reliability should be greater than 0.7. Now the issue is with regard to the average variance extracted and the construct reliability, etc. See, for this particular, if I go for a manual calculation, let me just show you a manual calculation. Then we will go for the software based, how the output of average variance extracted can be computed. So what is basically AVE, or average variance extracted, and how it can be calculated? Just give me 1 second. So AVE, basically the average variance extracted, it can be summation I is equal to 0 to n lambda square divided by n. Okay, summation lambda square divided by n. Now where lambda is basically the factor loading. Okay, n is the number of observed variables. So if I want to manually calculate the average variance extracted, so I need to go over here. You see, from 81 to 84, these are the factor loading. So these are the lambda score. So 0.929 square, plus 0.914 square, plus 0.862 square, plus 0.824 square divided by n. N is 4. So we are supposed to get the average variance extracted in that manner. Okay, so average variance extracted can be calculated manually in that way. And then we have another measure for convergent validity that we have seen, and it is the construct reliability, the CR. It should be greater than 0.7. Now how to compute? Again, if I want to do it manually, how can we compute actually CR? So let me have a very quick look into CR. CR basically is the composite reliability. So what CR is saying? CR is saying summation of I is equal to 0 to n lambda whole square divided by summation of I is equal to 0 to n lambda whole square plus summation of I is equal to 0 to n sigma whole square, where sigma is basically the error variance. Now how the error variance is to be calculated? The error variance is basically 1 minus lambda square. That gives you the error term. Okay, so if you want to manually compute it, again for a particular factor loading, for a particular, you can say, latent construct, say for example attitude, we have n is equal to 4, and then we have all the lambdas added up, and it will be whole squared, and then we get the error variance also, the error term also, and we can put the figure and we can manually compute it out. But there is a very interesting statistical package. I am sure that all of you are well aware about a website which is called StatWiki, StatWiki. If you visit this StatWiki, you will have access to one, which is called StatCraft. You can download it. It's an Excel computational file. Probably I am having it. Let me check. Yeah, it's called the stats tool package. If this is an Excel package, so let me open it up. uh, you see, it has a number of application. So you have the chi-square differences, you can calculate it. Two-way interactions, you can calculate. Group differences, you can calculate. Fit check, you can go for the effect size calculation. Then the heterogeneity test, even for outliers testing. Removal of missing values, or missing data imputation, scale assessment. So there are number of uh, assessment sheets are there. But in this case, we will use the first sheet, which is called the validity master, because we are basically checking the average variance extracted. For the convergent validity, we will go for the factor loadings. Factor loadings we have directly checked from here, that most of the factors are having a greater than 0.7 value, except for one particular factor which is critically disturbing this scale. So we can eliminate it from our final scale. This is 0.334. Scale means the measurement construct, we can delete it. And we are basically to check the average variance extracted, the composite reliability. And there is another thing that must not be forgotten. It is the discriminant validity. Okay, these are the three validity measures that we need to focus on: the convergent validity, and the discriminant validity. The discriminant validity says that the average variance between any two constructs should be greater than the sum of the squared correlation between the two constructs. Remember, this can be also done manually. And you have to take the individual factor loadings into consideration to calculate the AVE, and then you can get a understanding. You can compare between average variance extracted between two constructs, which should be greater than the sum of the squared correlation between the two constructs, to prove the discriminant validity. But everything, including the average variance extracted and construct reliability and discriminant validity, can be checked with the help of these stat packages. So in this validity master tool, or this validity master worksheet, actually it tests the validity of the confirmatory factor analysis. So what we need to do here is, you see, it has given certain kind of instruction already. You paste the correlation table in A2. This is column A, this is row 2. We need to paste the correlation table here, and paste the standardized regression weight in table F2. This is column F, this is row 2. So we have to paste the standardized regression weight here. So these two are our homework. So we go back here. Okay. The first thing that we need to check is the correlation. So from the scalar, we select the correlation. This is the correlation table. So we select it, right click it, just copy it. Okay, go back to your Excel sheet. You just paste it here. So the correlation has been pasted over here. And then we have to paste the standardized regression weights in F2. This is column F, this is row 2. So again, you go back to this particular sheet, result sheet, standardized regression weight. You select it from the scalar distribution. You select standardized regression weight, right click, copy it, again visit the Excel sheet, and you paste it over here. Now your job is done. You have pasted the correlation, you have pasted the standardized regression weight that came as an output of the confirmatory factor analysis. The final step is you just click this red button. So everything is done. Now you just click this red button. You just click it. You see, this is the composite reliability. See, the first thing that you need to look is at the bottom, no validity concerns. So our measurement model holds good. See the composite reliability across these factors, latent factors, 0.862, 0.934, 0.947, 0.868. You see, all of them are greater than 0.7. Interestingly, you see this particular computation has actually discarded purchase behavior. We have seen that purchase behavior is basically lesser than point, point 0.7. We still tried to incorporate it, but the computational tool has actually discarded purchase behavior. Average variance extracted, it should be greater than zero point 0.5. You see, it is greater than 0.5 for all the latent construct. Normally, we report these two. We do not report MSV. MSV is basically maximum shared variance, and this is the maximum reliability. We do not need to report this in journal papers. Now, this part, this is the interesting part, this particular part, because this part talks about the discriminant validity. Now, to interpret that the discriminant validity has been established, all these off diagonal or all the scores in this principal diagonal, there is 0.796, 0.883, 0.925, 0.837. These scores should be greater than the individual, scores in the row. That means, say, 0.883 is greater than 0.223, 0.925 is greater than these two scores, 0.837 is greater than these three scores. So all the correlational scores should be lesser than the value in the principal diagonal. So once we are having this kind of a result, we can say that the discriminant validity has also been established. So our measurement model actually holds good. So now we can take our study forward, and we can actually have a test of the structural model. But let us stop here, since you have another session at 5:30. So on Monday, probably at the beginning of the session, I will try to show you how the structural model will be taken up. Anyway, see, unfortunately, if we go to, I haven't shown you one particular thing. We are all talking about the validity concern. The validity has been established, but if you see the model fit, unfortunately, if you see the GFI scores, the goodness of fit indices, the GFI is 0.602. Adjusted GFI is 0.442, and the other baseline comparisons like NFI or the TLI, this is the Tucker-Lewis index. I told you all these indices should be greater than 0.9 to actually interpret that the measurement model is a robust one and it's a good one. Unfortunately, this particular measurement model is not a very good model. Although we have reached validity, we have validated the model, but in terms of the goodness of fit indices, we cannot actually use this particular measurement model. This is not a good model. For to become a good model, all these GFI, AGFI scores should be greater than 0.9. You see, there is a badness of fit index over here, RMR value. It is 0.332, whereas we have said that the RMR and this RMACA, these two values should not be greater than 0.05 at any stage. RMACA for the default model is 0.288, and for the independence model it is 0.390. So both the RMACA and the RMR value, they are very high compared to their acceptable score of 0.05 or at least 0.04. So the measurement model, although it has been validated, it is a valid model. But if you ask whether it is a good model, it is a robust model, it actually does what it intends to do. That means adequately captures the latent construct. Unfortunately, it does not. It deals with the hypothetical data. Probably much more refinement in the observed variable list is required. But anyway, with the help of this model, we can have a dummy representation or a dummy test of this theoretical model. Although we know that while validating this measurement model, this perceived behavior has been discarded. See, perceived behavior as a latent construct has to be present, but unfortunately, the researcher has chosen three such observed variables which are not adequate measure for this perceived behavior as a latent construct. So the researcher has to go back, search out the literature, read more literature, and try to identify a newer set of observed variables that can adequately be representative of this perceived behavioral control. And since it is a reflective kind of a model that we are talking about, he or she need to identify a set of observed variables that should be under the influence of this perceived behavior. Okay, so let us stop over here and we can take up the structural equation. If I can find an alternative data set that will have a good GFI and a AGFI value, I will do with that data set only. But basically, we can do with this particular data set to have an understanding how the structural equation takes place. Okay, so I can stop